So I'll quickly go over the final exam handout with you. So you're going to get table B, and this is used for finding probabilities in a normal distribution and also finding the p-values in a z procedure. So that is the first page is the negative side of the normal distribution, standard normal distribution, and the second page is the positive side of the standard normal distribution. Then you're also given table C. For the t distribution, you can find the one-sided and two-sided p-values given the degrees of freedom. You can also find the t star based on the degrees of freedom and the confidence level. You can also find the z star in the same table. Then you'll be given table D, which is the chi-squared distribution table, to find the p-values based on the degrees of freedom. The degrees of freedom in a chi-squared distribution is not the sample size minus 1, it is the number of buckets or bins in the problem minus 1. And then you're given the probability flowchart, where you decide whether a problem is an AND problem or an OR problem. That is, suppose you have probability of A and B, or the probability of A or B. So depending on what you have, if you have an AND problem, then you have to check whether the events A and B are independent or not. If the two events are independent, then you use the direct multiplication of the two probabilities formula, and if not, you multiply the probability of the first plus the conditional probability of the second, given that the first happened. You're also given this formula. Probability of B given A is probability of A and B divided by probability of the second event, which is A. If it's an OR problem, so for example, if you have A or B and you have to find the probability of it, figure out if A and B are disjoint, which means non-overlapping. If they're non-overlapping, then the formula is pretty straightforward. You just add the two probabilities. If they're overlapping events, then you use the addition formula, which is P of A plus P of B, but then we subtract the overlap because the overlap has been counted twice. So P of A is this. Notice that the overlap is counted once. P of B is this. We've gone over the overlap twice, and that's why this overlap has been counted twice. So if we subtract it once, then that kind of fixes the problem. Now the next page, you're going to see a lot of information. So this is the single sample problems. Make sure first that the problem is a single sample problem, not a two independent sample problem. So if it's a single sample problem, you need to decide whether P is given, whether sigma is given or not. Sigma is the population standard deviation. If sigma is given, we use the Z procedures. When you read the question, if the question says estimate the mean or find the mean, then we construct a confidence interval. If we have to prove something, then we do a hypothesis test. And if you look inside this box, you're given the formula x bar plus or minus z star sigma over radical n. It also tells you that z star can be found in table C at a certain confidence level C. So that would be either a 95% confidence level or a confidence level of 90%. For a hypothesis test, the z statistic, since it's a z procedure, is given by x bar minus mu o divided by sigma over radical n. and x bar is the sample mean. Mu O comes from the null and alternative hypothesis. The null hypothesis always has an equal to. So it's HO, put a colon, mu, the population mean, equals something, whatever the problem, based on the problem, you're going to select your mu O. The alternative hypothesis, again, HA uppercase H, subscript A colon, mu, the population's mean, less than mu O, greater than mu O, or not equal to mu O. You have to pick one of these based on the question. And then all the steps are given here. It says use table B to find the p-value, find the area of the tail for a one-sided test. So the tail could be the left tail, which is basically the area from the table. So this is the table entry. But if we need to find the right tail, then we find the area to the left, everything to the left. Let's say that's the area from the table. You have to go 1 minus that area in order to find the area to the right. So that's how you find the p-value. P-value is the area of the tails. If it's a two-tailed test, which means if you have a not equal to, it's a two-sided test if you have a not equal to, you find the area of the tail from your z-statistic and multiply it by 2. Because of symmetricity, the areas of both the tails will be the same, and that's the reason why you multiply by 2. That's how you find your p-value. So if the p-value is less than 0.05, we reject HO. P-value greater than alpha, which is 0.05, we fail to reject HO. The conclusion must be a full sentence including the p-value and mention the strength of the test. If HO is rejected, so you need to mention the p-value in your conclusion. So these are basically covering the important parts of the solve step in the 4-step process. So this is how you do the solve part of the problem. Now if sigma is not given, we use S. The sigma is the population standard deviation. We use S, which is the sample standard deviation. If sigma is not given, we use the T procedures. And of course, depending on whether we need to construct a confidence interval or do a hypothesis test, we go in different directions. The formulas are given in each of the boxes. T star comes from table C for a given confidence level. If a confidence level is not given, you pick a 90 or a 95, and based on the degrees of freedom, you find T star. So next, it's the hypothesis test. If it's the hypothesis test, this is the formula we use for the T statistic, but the first thing you have to do anyway is to find the null and alternative hypothesis. The null hypothesis, again, since it's a single sample problem, there's only one mu and whatever this number is. And your alternative, this is your null hypothesis. Alternative hypothesis is any one of these. So again, the solve part of the problem, all the steps in the solve part are given, although you have to write the statement, which is the state, formulate, solve, and then of course conclude. So this shows us how to do all the work. Just read all the information. You don't need to memorize anything because it's all in here. What you need to do is read the problem and decide whether it's a single sample problem or not, is sigma given or not, which tells us whether we use a Z procedure or a T procedure. Once we decide that, is it a confidence interval that estimates the mean that the question asks us to figure out, or is it a hypothesis test? That's what you need to do. The rest of the process or the solution is given in this chart. Now, what looks like a two-sample problem, it's not always a two-sample problem. there are two possibilities. It could be a matched pair problem when there is a single sample that gives us two columns of values, right? It almost looks like a two sample problem. But for example, if the same sample is given two treatments, treatment 1 and treatment 2, or drug 1 and drug 2, then what we have is a matched pair problem. So make sure you know what a matched pair problem is. And then if there are two different samples being given two different treatments, for example, then that would be a two independent sample problem. Read the question to figure out whether you need to construct a confidence interval or a hypothesis test. Once you decide on that, all the information is given here. Remember that a matched pair problem really turns into a single sample problem because we take the difference of the pairs of values. We create a third column, which is the difference. And once we create the third column, that's all we do. We work with the third column. And when it's a single sample problem, basically it becomes a single sample problem. We have only one mu, and mu equals 0 is always the HO. But the HA could be mu less than 0, mu greater than 0, mu not equal to 0, depending on the problem. If it's two independent samples, notice there are two mu's, two s's as a standard deviation of each sample, since there are two samples, and two possible sample sizes if there are two samples. And basically the rest is just plugging numbers into the problem. So the solve part is taken care of in these two charts. There's nothing to memorize. Everything is in here. You have the tables, and in fact, each of these boxes gives you exactly what you need to do for that particular problem. But remember that a 4-step problem has state, formulate, solve, and conclude. State is a general statement of what the problem is asking you to do. If it's a confidence interval, you say, we will estimate the mean, and then you keep going whatever that problem is. Formulate is where you explain which procedure you are using and why. For example, you could say, since sigma is not given, we will use the single sample t procedure to construct a confidence interval or to do a hypothesis test. So you got to explain which process you're using and why. So for example, if it's a matched pair design, you're going to say, since this is a matched pair design, we will take the difference and do a single sample t procedure either to construct a confidence interval or a hypothesis test. So that's the part which is formulate, just explaining which method you use and why. Solve is basically the calculations, the setting up. If it's a hypothesis test, for example, you set up the null and alternative hypothesis, figure out the t, use the table C to find the p-value, and then, of course, make a formal conclusion. If we are constructing a confidence interval, we're going to start with we are 90% confident, or we are 95% confident that the mean lies between this number and this number. If it's a hypothesis test, we'll say we have evidence or strong evidence. Evidence is the p-value. You're going to mention that in the conclusion. We have strong evidence to prove that the mean IQ scores of 7th graders in this particular district is much greater than that of the general population, or something like that. Make a general statement. So this is how it works. Make sure you understand what's in this chart, and you're allowed to print this out and use it during the exam.